So let's just see the example number 2. Example number 2 says check whether the polynomial qt is a multiple of 2t plus 1. So we have to check whether this polynomial is a multiple of 2t plus 1. So it means that if 2t plus 1 can able to divide qt, then definitely it is nothing but called as the multiple of 2t plus 1. So it means that 2t plus 1 can divide this whole polynomial fully, means the remainder should be is equal to 0. That is why this particular qt is called as the multiple of 2t plus 1. So in order to check whether the polynomial is a multiple of 2t plus 1, we have to prove that the remainder that we are getting after dividing these two polynomials should be is equal to 0. So if the remainder is 0, then it should be a multiple, and if the remainder is not is equal to 0, it means that it is not the multiple of 2t plus 1. So let's just see. Let us suppose we are having 2t plus 1 as a linear polynomial. Now, as we know, 2t plus 1 is the linear polynomial. It is the linear polynomial. So as per the remainder theorem, we have to find out the value of the a. A means the zeros. A means the zeros. So it means that we can find the zeros of this particular polynomial as substitute 2t plus 1 is equal to 0. We are getting the value of t as nothing but minus 1 by 2. So this minus 1 by 2 is nothing the value a. So here a is minus of 1 by 2. So substitute this value into this particular polynomial. So substitute a as minus 1 by 2 in this polynomial. So it is like q of t. So the value of t is minus 1 by 2. Substitute this value as 4 minus 1 by 2 whole cube plus 4 minus 1 by 2 whole square minus 1 by 2 minus of 1. Now let's just solve it. It is 4. It is minus 1 by 2 means minus 1 by 2 gets multiplied with itself 3 times. So it will be minus 1 by 8 plus of 4 into 1 by 4 minus plus 1 by 2 minus of 1. So let us suppose we are cancelling out the values as 4 into 1 is 4, 4 into 2 is 8, 4 and 4 get cancelled with each other. So it is minus of 1 by 2 plus of 1 plus of 1 by 2 minus of 1. So half and minus half get cancelled with each other, and further we have 1 and minus 1, they both are get cancelled with each other because it is plus 1, it is minus 1. At the end what we are getting the remainder as nothing but is equal to 0. So if the remainder of both of these, or after dividing both of these polynomial is nothing but is equal to 0, then it definitely means that this polynomial is nothing but a multiple of 2t plus 1. Why so? Because we do know that we can write 4t cube plus 4t square minus t minus of 1 as dividend, which is equal to divisor into quotient. Divisor, let us suppose I am taking the divisor as 2t plus 1. There should be some quotient. Let us suppose I am taking it as qx, and the remainder is r of x. And we do know that the remainder of this particular polynomial is nothing but after dividing these two polynomial is nothing but 0. So at the end what we are getting that 4t cube plus 4t square minus of t minus of 1 can be written as 2t plus 1 into qx, where the remainder is nothing but is equal to 0, because we are getting this result using the remainder theorem. So hence at the end what we can say that this is nothing but a multiple of 2t plus 1, or we can say 2t plus 1 and qx is nothing but a factor of this particular polynomial, that is 4t cube plus 4t square minus t minus of 1. So at the end what we are writing that 2t plus 1 and qx are the factors of qt. So I'm writing t over here because the polynomial wasn't t. So we cannot write x. We have to write it as t. So let us suppose I'm taking it as t. I'm taking it as t because the variable that we are using is t. So we cannot take it as x. So let us suppose I am correcting it as t. So we are using over here as t because the polynomial is in t. Again, we are taking it as t. So t. So this is 2t plus 1 and qt. They are the factors of the polynomial q of t. Again, we are using the polynomial over here as q of t. So we cannot take it as q of t because the quotient should be different. So let us suppose I am considering it as g of t. So let us I am taking it as g of t, and again I am taking it as g of t. Always remember that we always have to take the quotient and the dividend and the representation of the divisors in a different way. So if this is given us as q of t, so we cannot take the divisor or the quotient as q of t. So I am taking it as g of t. So again this is g of t, again this is g of t. So there must be two factors, that is 2t plus 1 and g of t, which are the factors of q of t. Or what we can say that qt is a multiple of 2t plus 1. So we have proven this fact that yes, qt is a multiple of 2t plus 1 using the remainder theorem. This is all about the remainder theorem. We have used the remainder theorem over here. So let us suppose I am writing it over here as by remainder theorem we have proved this result. If the remainder of dividing these two polynomial, if the remainder is coming out to be 0, then it definitely means that this particular polynomial is a multiple of 2t plus 1, or what we can say else, that 2t plus 1 and there must exist some g of t, which are nothing but the factors of this polynomial q of t. So this is all about using the remainder theorem in order to solve such type of questions.